Hello, Mr. Randy here. Time for week 5. This will be part 1. As usual, we're going to look at a variety of new things this week, and we're going to begin with thin features. So far, everything we've sketched has been a closed loop, like a rectangle. So if I went to the front plane and I sketched a rectangle, that's a closed loop. It's a closed shape. It'll have volume when we extrude it. This whole interior would be filled in with material. But we're going to look at thin features today, a little bit different. So let's just create kind of an L-shaped sketch here. And I'm just going to extrude this. So unlike everything we've done so far, this is an open shape. So we're going to go right to feature and we're going to say extrude. And SolidWorks typically, but not always, is going to make the assumption that we're after a thin feature. Certainly it has in this case. In fact, it's grayed out, which means we can't even turn it off. A few things you have to be careful of when you're doing thin features. I'm going to stretch this out. When you're doing thin features, first of all, make a decision on direction. If you need to. Secondly, be real careful in your assignments. The thin feature, you have options here. You can go mid-plane around the sketch. I hope you can see the difference. This is the lines I drew, and it's creating the thickness mid-plane. In other words, it's giving me, in this case, 5 millimeters in each direction. You can go one direction, in this case all to the outside, if you will. If I flip direction here, it's going to go all to the inside. So watch your sketches very carefully as you produce your geometry and make sure that you're going in the right direction or mid-plane. You can also go two direction, and it gives you two dialog boxes. So I could say go 2 millimeters out and 6 millimeters in, and get an uneven offset, if you will. Pretty simple and straightforward in terms of how you produce the geometry, but do be careful again. Watch your dimensions very carefully. All right, let's delete that feature, and let's go ahead and delete that sketch. So that's an extruded thin feature, but we can also do a revolve thin feature. So let's go to the front plane and start a sketch. And I'm going to do a center line for the middle of my part here. And I'm just going to draw a real simple profile here. So let's just draw a series of lines here. This ought to look interesting. So here's my open profile again, not a closed profile. And this is my line for revolution. And a thin feature in a revolve behaves differently when you first click on the button. So I want you to see what happens here. So we're going to do a revolved base here. And when I click on this, SolidWorks is going to give me this note, this warning. And it's going to say, the sketch is currently open. A non-thin revolution requires a closed sketch. Would you like the sketch to be automatically closed? Well, if you say yes to this, SolidWorks is going to draw the line between your open endpoints and then produce the revolve. And I'm going to go ahead and do that just so you can see what it did. So this is truly a revolved solid. I'm going to hit OK just for the fun of it. And you can see it's definitely not a thin feature. It's very solid. And in fact, let's go back and edit that sketch. And you can see that SolidWorks put the line in. So it actually modified my sketch. Well, it's not what we wanted, so let's delete that revolve. Yes. And let's edit this sketch and take that line back out. So I'll say goodbye to that line. And then let's do this again. Let's create a revolve feature. And this time we're going to say no. And now SolidWorks is going to create a thin feature. We're going to go, let's just go mid-plane. And let's pick something thinner here because I've got some pretty tight angles here. And I hope you can see, if I look right here, the material thickness, you can see it's kind of grayer here than the yellow of the rest of it. So you can see the thin wall here of the part, mid-plane offset around the line geometry. In this case, because my geometry did not come to the center line, I have an opening here, right? All right, so we'll hit OK, and now you can see this hollowed out part. Let's look at it in section here real quick. There you go. And you can see our hollowed out profile. It's a thin feature, all right? Pretty straightforward. Now, let's take a look at your assignments. So here's your first assignment of the week. It will be a thin feature revolve. Notice that the dimensions are to the sharp corners, but you must put these in as sketch fillets. Don't do a fillet afterwards, or your interior won't follow this profile for our martini glass. Likewise down here. So you've got to put these in as sketch fillets after you've dimensioned to the sharp corners. Be very careful when you revolve this. The wall thickness is 1/8 of an inch. Pretty heavy martini glass, but and if you don't offset in the right direction, your stem's going to have a hole through it, which means that your poor martini will wind up on the bar. So make sure that your wall thickness is going in the right direction to close the stem up. Okay. The second thin feature assignment is an extrude. It's 10 inches long. It's a ribbed piece of fascia like you might find on the outside of your house. What I want you to take note of here is that, as we can see in this detail here, the dimensions are to the outside edge. Likewise, if I look at this detail, all the dimensions are going to the outside edges of the part. When you extrude this, your sketch will be this outer edge. So make sure your thin feature is going in the right direction so that this sketched edge that you created is the outside, not the inside of this L shape. Okay? All right, next up. We're going to do some linear patterns this week and some mirrored features. And this part has both in it. So I just want to talk about this part just a little bit before we jump in. There is a single counterbore hole here, and it has a depth of 2 millimeters. So it's a modified or custom hole because that's not the normal depth. So first of all, be careful of that. Then we're going to linear pattern it, and in one step we're going to create all these holes. So it's going to have a linear pattern both in this direction and this direction, and we're going to omit the 3 holes in the middle. We'll do all that in one linear pattern. There is a hole wizard hole right here in the center of that boss. It's a 7-through wall with a countersink. Now remember, the largest metric screw that would fit in that hole wizard hole is a 6 millimeter screw. We can't put a 7 millimeter screw in a 7 millimeter hole without a hammer. So it's going to be an M6 flathead screw for the hole wizard hole that's in the center of that boss. We have a radial slot here. I want you to sketch and cut this radial slot. It's going to be mirrored over here as a feature. If you mirror it in the sketch, it's going to get marked wrong. So don't mirror it in the sketch. And then likewise, we have 4 triangle cuts here at a depth of 6 millimeters, so do note that. And those triangle cuts, again, I want you to do one of them, cut it 6 millimeters down, then mirror it up to here, and then take these 2 and mirror them over to here. Do not mirror the sketches. I will mark it wrong. I will deduct points. The goal this week is to work with mirrored features. Okay? All right. So I'm going to draw part of this part because I want to show you a couple of these things in SolidWorks. So let's take a look at SolidWorks here. So new file, this is a metric part. And I'm going to go to the top plane. I'm going to start a sketch. I'm going to do a rectangle. And I need, let's go back and look at this for just a second. We have a big decision to make here. I need a mirror plane through the middle of the part here because I'm mirroring these slots and these triangles from left to right around the center of this part. I'm also mirroring these features top to bottom, if you will, in this view, around the middle of the part this way. Well, when we create mirrors as a feature, you must have a face or a plane to click on for the mirror plane. In AutoCAD, when we work in 2D or even a 2D sketch in SolidWorks, we can use a line, or in SolidWorks a center line, as the mirror line. But in 3D, you must have a planar surface, a 3D surface, if you will. It's actually a 2D surface, but so a plane or a surface on the part. So I'd really like, in fact I need, to make the origin in the middle of my part so that the right plane will be here to mirror left to right, and the front plane will be here so that I can mirror from front to back. All right, so back to our part. I'm going to do a rectangle, and I'm going to sketch it like that, and I'm going to dimension 112 and 60, and I'm going to drag this up like so, and I want to kick back to my drawing one more time at this moment. I want you to notice that I gave you a 56 millimeter diameter here actually to locate the boss, and a 30 millimeter dimension, I'm sorry, not diameter, 30 millimeter dimension to locate the boss this way. Well, I'm going to do this just a little differently. It's the same requirements, but I'm going to use these dimensions right now in my base sketch and place the origin right there. So let's take a look. I'm going to do a smart dimension from here to the origin of 56, and then from here to the origin of 30. Then when I draw the boss, I'll just drop it on the origin. These dimensions will still work perfectly fine if I have to change the part down the road. So we're going to extrude that, and the thickness is 10 millimeters. Now, I'm not going to draw the boss. You can do that. Just be careful where you sketch it and how you create the dimension for it. I do want to double check this, make sure I got 10. I did. Okay, very good. All right, so I'm going to put the first hole in. Again, this is a custom hole. It's an M4 hole that is only 2 millimeters deep. So I'm going to click on that surface. I'm going to go to Hole Wizard. We want a counterbore hole, ANSI metric. It'll be a socket head cap screw, M4. And I'm going to scroll down here, and we're going to say Show Custom Sizing. And the depth of the counterbore by default is 4 millimeters, and we're going to make it 2. Okay, so again, custom sizing and 2 millimeters. I'm going to go to Positions now, and I'm just going to drop a point right there. And let's go normal 2, and I'm going to dimension that, and the location is 8 millimeters off of both edges. Like so. All right, so there's my first hole, and I'm going to go ahead and say OK. So I now have a 2 millimeter deep counterbore hole there. Now if we take a look at the drawing, you can see we have a pattern of 1, 2, 3, 4, 5, 6, 7 by 3, 16 millimeter spacing and 22 millimeter spacing. Let's take a look at how we'll accomplish that. I kind of like to pre-select, so I like to get it highlighted because then when I hit linear pattern it'll already be selected, but we'll do it the other way just so you can see it. So the first thing it wants to know is direction 1. So we're going to pattern in this direction first. You have to have an edge, or you have to create a sketch and put a line in there and just close the sketch. But we'll have edges, so we don't need that. So I'm going to click this edge. And you can see a very small arrowhead right there, pointing in the direction of the pattern. Make sure it's going the way you want it to. It might come in that way, so be careful. It depends on where you click on the line. And we'd like spacing to be 16 millimeters. And let's go ahead and click here, Features to Pattern. And I can pick the counterbore hole here, or I can click the plus mark here and pick it in Feature Manager. All right, let's go back up here. So edge 1, 16 millimeters. There we go. And I need 7. Is that what we said? All right. Then for direction 2, I'll pick this edge. And I need 3 of them. And the spacing is going to be 22. Well, it's a lovely pattern, but if you remember, the middle 3 holes have to come out because we have a radial slot here, and we have this boss in the center with a different hole wizard hole. So let me show you how to do that. We're going to scroll down, and instances to skip is the box we need. And when I click on this, if you watch the drawing or the model, a purple dot appears for every hole except the original. And all I have to do, so you can see instance to skip is active right now because the box is blue. All I have to do is click on that purple dot for the holes that I don't want. So I'll turn those off. By the way, if you click on them a second time, they come back on. If you can go back, edit the feature, just click in this box and then turn on or off anything you want. Let's hit OK. And there's my hole pattern. All right. I'm going to do one more here. So let's click on this top face and let's start a sketch. And I'm going to do that angled cut there. So let's go normal 2. And let's draw some line geometry here and create that triangle. All right, so I need a dimension of 10 millimeters here. And I need a dimension of 75. So I've messed up because I think I put a perpendicular relation in there. I sure did. I saw it following the witness line and it didn't stop. I need 75 here. And it is 20 millimeters there. And I think you can see I'm missing something here, and I think all I need to do is probably make these 2 lines equal because I didn't give you a second angular dimension for half the distance. And that gets us fully defined. I'm going to cut that 6 millimeters. And there's that first cut. I should mention right here that would have been helpful for me to have put the fillets in first. I have a lot less clicking to do if I'd have put the fillets in on these corners before I started this cut, but that's all right. All right, so we'll mirror this up to this position. So let's take a look at the mirror tool here. So there's mirror. Now cut extrude was highlighted, so it automatically selected it. You could also click in this box and pick features to mirror. For the mirror face or plane, we're going to grab the front plane. The front plane should be slicing right through the middle of my part here. And you can see it's created the reflection here on the back side, and we'll hit OK. So I have the first 2. Now I need 2 over on this side. So we're going to mirror. And for my mirror plane, I'm going to use the right plane this time. And for features to mirror, I'm going to grab the cut extrude. That gets me that one. And I'm going to grab the mirror, which will give me that one. And we'll click OK. So that's the mirror tool, and we'll use the mirror tool in other places this semester. That's how that works. Again, we're using planes now, not lines, so get out of that AutoCAD mode. I'll let you put the boss in and the radial slots and get that all wrapped up. So let's move on. take a look at one last problem here. This one is rather fun. So we have a hexagon, and we have a bunch of features that are patterned in a circular pattern here. We have a hole wizard hole that we have 3 of. We have this beaker shaped slot that we have 3 of. And we have this rather odd cross hole here that we have 3 of. Let's really fast get this one going. I'm going to go to the front plane, new file, metric part. We'll go to the front plane, we'll start a sketch, and I'm going to do a polygon. It is 200 across flats. Oops. And we'll make this line horizontal. We'll extrude that 100 millimeters. All right, so let's do some quick operations here. Let's flip back to the drawing for just a second. First thing I'm going to do is this beaker cut. I want you to notice there is a 12 and a 24 millimeter dimension for that cut. I need you to be real careful on that one. Do not create relationships that eliminate that 12 millimeter dimension. So front plane, start a sketch. Let's go normal 2. I'm going to do a line like so and like so. I'm going to do a circle from here. I'm going to trim just the lines for right now. I'm going to dimension that diameter because it is given as a diameter of 60. And then I'll trim and get rid of that piece. That saved me from messing with the dimension. I guess I should close this. Now I'm going to dimension from here to here, 12 millimeters, and then across 24. Fully defined. I'm going to cut that. And it's cut 80 millimeters. We'll hit OK. Now I'm not going to pattern it. I'm going to let you put the hole wizard hole in. Make sure you get the right one in. I'm not even going to go back and look at those dimensions. But I do want to look at the rather strange crossed hole through here. So I want you to see that there's an 80 millimeter hole in the middle of the part here. And then there's a counterbore hole coming out to the outside. Well, I can't create a plane here to sketch on because I don't have a dimension and I'm not doing any math. So there's got to be a way to make this right, or Mr. Randy wouldn't have given this to you. What I'm going to do is I'm going to mid-plane cut the 80 millimeter distanced hole here, and then on the end of the hole I'm going to sketch and cut this counterbore, if you will. This is not a hole wizard hole. There's no way to make this happen as a hole wizard hole. Let's take a look at that. I'm going to go to the right plane, which is in the middle of the part, and I'm going to start a sketch. And we can go normal 2, and I'll just draw a circle, and I'll dimension that with a diameter of 20, and it is off the middle of the part, 70 up, and it is 40 back from the front face. And I'm going to mid-plane cut that. So we're going to do a feature extruded cut, mid-plane, and 80 millimeters, and I'll hit OK. Well, we have a bit of a problem here because I can't see the bottom of the hole. I have to click on the bottom. You can see it right there. I have to click on the bottom of that hole in order to start my sketch for my counterbore. Well, let's go to wireframe here. Now we can see it. So let's spin this around, kind of. So if I put my mouse right there and I click, what do I get? You can see that it's lit up this face here. It's not lighting up this face. Well, I could click right there, but I can't start a sketch because I'm getting the edge. Well, this is a bit of a perplexing problem, but SolidWorks has the solution for us. So what I'm going to do is I'm going to put my mouse right in the middle of this face. Now, my mouse right now is sitting on about 4 or 5 different faces here. So let's talk about that. It's sitting on this rectangular face, right? It's sitting on this circular face. It is technically sitting on this rectangular face here. It's not sitting on the back face, because no, it is sitting on the back. So it's also sitting on the back, the hexagon. All those faces cross through where my mouse pointer is at this moment in time. I'm going to right click, not left click, I'm going to right click with my mouse right in the middle of that circular face. And I'm going to mouse to this, and this is called Select Other, and it's not a commonly used tool, but there are certain situations when you need it, and there's no other solution to the problem. So here we go, Select Other. It's going to pop up a little menu for me, and this menu is going to light up all the various faces that are underneath the mouse. Now again, you can see right now the back face is lit up. And I'm going to mouse down through, and I'll start at the bottom. So there's the back face. I'm going to mouse up. There is the bottom of the keyhole cut. There is that rectangular side face of the keyhole cut. This is the cylindrical surface of the hole. And then finally, right at the first one, this is the end face of that hole. That's the face I want to sketch on. So I'm going to click on that face. Now you have to be very careful. That face is now lit up blue. If I click anywhere on the screen, I'm going to lose it, and I'll have to go back through that step. So I want you to go straight over, click on Sketch, Sketch. It's the only time we have to go through that process to get to a sketch. I can't get the little pop-up menu. In order to start that sketch on that face, I'm going to draw a circle. I'm going to touch and drag. And you should be able to tell right away if you did it right, because that circle should be right on the end plane there. All right. I'm going to do this a little funny, just for giggles, just so you can see something rather interesting. So let's go 30 millimeter diameter, and let's do a feature extruded cut, and I'm going to say up to surface, just for the fun of it, and pick that surface and hit OK. And there's my cut. The reason I did that is I want you to see what happens in the mirror. So I'm going to click on mirror, and for mirror face I'm going to pick the right plane, and it has the cut extrude. And this is what's very fascinating to me, is that you can see the mirror right there. Looks beautiful, doesn't it? You can see the preview. I'm going to click OK, and something rather bizarre has happened. So instead of giving us the mirror, I have that. So what do you think happened here? Well, SolidWorks, when you say cut up to surface and you pick that surface, the cut is tied to that surface. Likewise, the mirrored feature is tied to this surface. So what happened there was that it mirrored it over here and cut it through all back to this surface. So I want you to understand that while in the sketch or in AutoCAD, when you mirror something, it just duplicates the geometry on the other side. In 3D, if you've tied that geometry as a feature to some surface or a plane or something, all of the mirrored copies are going to connect to that plane or surface. It's not a geometry pattern. It's not a geometry thing, if you will. So we can't quite do that. So I'm going to go back and edit that feature, and we'll just say through all or up to next. I think either would work. And there we have the solution. Now let's pretend that we have the whole wizard hole in there. I'm not going to do that. One of the requirements of this assignment, so do read your instructions, is you must only do one circular pattern. So I'm going to do that. I'm just going to omit the hole. Well, we're going to go to circular pattern. It's hiding down here. Here's circular pattern. It's underneath linear pattern. And it needs an axis, and it doesn't really tell you here what that means unless you put your mouse there. And it says, where's the pattern axis? Well, it's the middle of the hole here. I don't have an axis there. So I'm going to turn on temporary axes and pick that axis right there. So again, that's temporary axes. And click on that axis. And there it's patterned my hole, the cut extrude. I want 3 equally spaced. And we can see we've got some more geometry we got to get in the pattern here. So we need this cut first of all, the pattern, and then the hole cut, and then we need the mirrored pattern. So I think our preview has everything now. Let's hit OK. And there is our mirrored features. Okay. Let's go back to wireframe, or solid, I'm sorry. And we can see all those holes. Again, you would have put the hole wizard hole in first and also patterned that. Okay. All right. I'm going to come back with part 2 and finish up the last couple parts. And as always, enjoy.